What does it take to build a BMW 3 Series? Not just assemble it, not just paint it, not just bolt on wheels and send it to a showroom. To build a 3 Series, BMW has to turn flat sheets of metal into a rigid body, join hundreds of parts with robotic precision, paint the shell until the surface looks like liquid glass, install thousands of components in the exact order, connect the powertrain, wake up the electronics, test every function, and inspect the car again and again before it ever reaches a customer. And here is the most interesting part. Every car on the line can be different. One 3 Series might be a classic sedan in a simple color. The next might be a plug-in hybrid with different electronics, special wheels, a unique interior, and a completely different destination market. But inside the factory, all of that complexity has to move like a perfectly timed machine. So today, we are going inside the world of BMW manufacturing to see how the BMW 3 Series is made, from raw metal to a finished premium sports sedan. The BMW 3 Series is not just another car in BMW's lineup. For decades, it has been one of the brand's most important models, the car many people think of when they hear the word sports sedan. Today, 3 Series production is part of a global manufacturing network. BMW builds the model in places such as Munich in Germany, Shenyang in China, San Luis Potosí in Mexico, and several regional plants for local markets. The Munich plant is especially important because it is BMW's historic home plant, and it has been connected with 3 Series production since the first generation. But whether the car is built in Germany, Mexico, China, or another market, the mission is the same: precision, repeatability, flexibility, and premium quality. The process begins long before the first metal part is pressed into shape. Engineers plan the factory digitally, check production lines virtually, simulate movements, study worker ergonomics, and make sure every new model can move through the plant without colliding with equipment or slowing down the line. In modern BMW production, the factory is not only physical, it is also digital. The real plant has a virtual twin. Production planners can walk through a digital version of the line, test layouts, simulate robots, check logistics, and prepare workers before the car enters full production. Once planning is complete, the first physical stage begins. Every BMW 3 Series starts with metal. Large coils and sheets of steel and aluminum arrive at the factory. These flat metal blanks do not look exciting at first, but soon they will become doors, hoods, fenders, roof panels, side frames, and structural parts of the car. Inside the press shop, huge machines shape the blanks with extreme force. A metal sheet slides into a press, the tool comes down, and in a moment the flat surface becomes a sculpted body panel. The curves, edges, character lines, and mounting points begin to appear. This stage is critical because the quality of the body starts here. If a panel is slightly wrong at the beginning, it can create problems later in welding, painting, assembly, and final fit. That is why BMW uses data tracking and quality systems in the press shop. Each blank can be identified and linked to production information. The factory monitors details such as material thickness, oil layer, press speed, and temperature. Instead of relying only on random checks, the production team can use data to spot irregularities quickly. Imagine thousands of panels being made every day. A human inspector could not study every detail with the same speed and consistency. But sensors and software can collect information instantly, compare it, and highlight where attention is needed. From here, the stamp parts move to the body shop. If the press shop creates the bones, the body shop builds the skeleton. This is where individual metal parts become the body in white, the unpainted vehicle shell. At this stage, the car has no paint, no engine, no interior, no glass, and no wheels. It is simply the raw structure of the future 3 Series. The body shop is one of the most robotic areas of the factory. Robotic arms lift parts, position them, clamp them, weld them, and join them with repeatability that is almost impossible by hand at this scale. The floor, side panels, roof structure, rear section, front structure, doors, hood, and trunk lid all come together step by step. Spot welds, adhesives, screws, and other joining methods are used depending on the material and location. Every joint has a purpose. strength, crash safety, stiffness, noise control, and long-term durability. This stage also affects the way the car drives. The BMW 3 Series is known for handling, and that character begins with the stiffness and accuracy of the body structure. If the body is strong and precise, the suspension can do its job better, the steering can feel more direct, and the cabin can remain quieter. Robots perform the repeated joining work, but people are still essential. Engineers, technicians, maintenance specialists, and quality teams supervise the process, monitor data, solve issues, and improve the system. In some BMW plants, sensors are used on welding equipment to predict maintenance needs. Instead of waiting for a tool to fail, the factory can detect changes and schedule maintenance during a planned break. That protects production time and prevents quality problems before they happen. After the body is joined, it is measured. The gaps, dimensions, and geometry must match strict tolerances. Doors must sit correctly. Mounting points must be exactly where they should be. Only then can the bare body move to paint. The paint shop is where the 3 Series starts to look like a real BMW. But painting a car is far more complex than spraying color on metal. Before the color coat is applied, the body has to be cleaned, protected, sealed, primed, painted, and finished. First, the bare body goes through cleaning and pre-treatment. This removes dirt, oils, and particles from the metal surface. Then the body receives corrosion protection, because a modern car must survive years of rain, heat, cold, road salt, washing, and daily use. Next comes sealing. Sealants are applied in specific areas to prevent water intrusion, reduce noise, and protect joints. Underbody protection and cavity preservation protect areas customers may never see, but that matter for long-term durability. Then comes primer, base coat, and clear coat. The primer creates a smooth and stable layer. The base coat gives the car its color. The clear coat adds shine, depth, and protection. BMW paint shops use advanced robots to apply paint evenly across the body. These robots can reach curves, edges, door openings, and difficult surfaces with consistent control. That consistency is important because premium paint is not only about color. It is about surface quality, depth, gloss, and uniformity. The paint shop is also one of the cleanest and most controlled areas in the plant. Dust is the enemy. Even a tiny particle can create a defect in the finish. That is why airflow, humidity, temperature, dust levels, and process conditions are monitored closely. At BMW, automated systems can scan painted bodies to find surface defects that the human eye may not notice at first. Inspection data can also help improve earlier paint processes. If a pattern appears, the team can investigate the cause and reduce rework. After painting and curing, the body is no longer just a metal shell. It now has color, protection, and identity. Next, it moves into assembly. Assembly is where the BMW 3 Series becomes a complete machine. At this stage, the painted body enters a long production line where thousands of components are installed. The exact sequence matters. Some parts must go in before others. Some components are unique to the customer's order. Some are linked to safety, electronics, comfort, or performance. The factory uses digital production systems to know exactly what each car needs. This is where flexibility becomes impressive. A blue 330i, a black plug-in hybrid, and an M Performance version can move through related processes with different parts, wiring, trim, and equipment. First, the doors may be removed from the body. That might sound strange, but it gives workers and robots more space to install interior components without scratching the painted surface. The doors are tracked separately and rejoin the same car later. Then the wiring harnesses are installed. These are the nervous system of the vehicle. Modern cars are packed with sensors, cameras, screens, control units, lighting systems, safety systems, audio systems, climate systems, and driver assistance features. All of them need power and communication. The dashboard support structure goes in. Air conditioning components are installed. Sound insulation, carpets, roof liner, pedals, airbags, control modules, and interior trim begin to fill the cabin. The seats are prepared according to the exact configuration. Depending on a model and market, the seat design, upholstery, heating, memory functions, and safety equipment can vary. In Munich, BMW has an in-house seat manufacturing facility that supplies seats directly to vehicle assembly in the correct sequence. This just-in-sequence delivery is one of the hidden miracles of car manufacturing. The right seat has to arrive at the right station at the right time for the right car. If a car is configured with a specific color, stitching, and option package, the seat must match. One of the most famous moments in car assembly is called the marriage. This is when the body of the car meets the drivetrain and chassis. Under the line, a complete module is prepared. It can include the engine or hybrid drive components, transmission, suspension, axles, steering parts, exhaust system, and other major underbody elements. Above it, the painted body approaches. Then, with precise alignment, the body is lowered onto the drivetrain and chassis module. Bolts are tightened. Connections are made. The car gains its mechanical heart. For a BMW 3 Series, this stage matters because driving character is part of the car's identity. The engine, transmission, suspension geometry, steering system, and chassis tuning all contribute to the way the car feels. The factory must assemble these systems precisely because even a small error can affect noise, vibration, alignment, or performance. After the marriage, the vehicle starts to feel like a car. The suspension is attached. Brake lines and fuel or high-voltage systems are connected depending on the version. Cooling systems are fitted. Wheels and tires are prepared. The underbody becomes complete. The line continues, and more exterior parts are added. Headlights, taillights, bumpers, grills, badges, glass, mirrors, and trim pieces all come together. The doors return to the body. The interior becomes complete. The car now has its shape, color, cabin, and drivetrain. But it is not ready yet. Now the factory has to wake it up. A modern BMW is both a mechanical product and a digital product. So once the main components are installed, the vehicle's control units must be programmed, checked, and connected. Software is loaded. Electronic systems are initialized. The car learns what equipment it has and how each system should behave. At the same time, the vehicle receives operating fluids. Depending on the model, this can include coolant, brake fluid, washer fluid, air conditioning refrigerant, fuel, and other necessary fluids. Plug-in hybrid versions add more complexity because their high-voltage systems require additional safety and validation steps. The battery is connected. The electronics come alive. Screens can power on. Lights can be checked. Windows, locks, wipers, seats, climate controls, sensors, and driver assistance functions are tested. This is one of the most satisfying moments in the factory. A vehicle that started as metal sheets is now responding like a living machine. But BMW does not simply trust that everything works. It verifies. Quality control happens throughout the entire production process, not only at the end. In the press shop, data helps detect irregularities in metal forming. In the body shop, measurements confirm the structure is accurate. In the paint shop, sensors and automated surface inspection help protect the finish. In assembly, cameras, RFID systems, digital tools, and workers check that the right parts are installed correctly. Artificial intelligence is increasingly used to support these checks. Image recognition can compare parts against known correct examples and detect whether something is missing, incorrectly positioned, or not fitted properly. This is especially useful for small items that are easy to overlook but important for final quality. For example, a system can help confirm whether specific trim pieces, caps, labels, or safety items are in place. The advantage is speed and consistency. The factory can make decisions in fractions of a second, and workers can focus on solving problems instead of repeating the same visual check thousands of times. After assembly, the completed 3 Series goes through final tests. The brakes are tested. The chassis and lighting are checked. The wheels are aligned. The car may run on a dynamometer, where the wheels spin while the vehicle stays in place. This allows the factory to test drivetrain behavior, electronic systems, and performance functions in a controlled environment. Lights are adjusted. driver assistance sensors may be calibrated. The welcome lights, cameras, comfort systems, and other features are verified. The body surface is checked again under special lighting. Gaps and flushness are inspected. Interior fit and finish are reviewed. Any issue is corrected before the car is released. Some vehicles also go through water testing to make sure seals are correct. Others may be driven on a short test route to check noise, vibration, braking, steering, and a general function. The goal is simple. When the customer receives the car, it should feel new, solid, precise, and premium from the first moment. Building the car is only half the story. Getting every part to the line at the right time is another massive challenge. A BMW 3 Series contains thousands of components from many suppliers and internal BMW locations. Engines, transmissions, electronics, glass, seats, wheels, tires, interior modules, cables, sensors, and trim parts all have to arrive in the correct sequence. Factories use advanced logistics systems to manage this flow. Some parts are stored nearby. Some arrive just in time. Some arrive just in sequence, meaning they're delivered to the line in the exact order the cars need them. To manage that complexity, BMW uses digital tracking, automated transport systems, smart devices, and production software. The car itself becomes part of the information flow. It is not just moving down the line. It is carrying a digital identity that tells the factory what it needs. This is why modern automotive manufacturing is so impressive. It is not only about robots. It is about coordination. BMW's factories also have to think about sustainability. Paint shops traditionally use large amounts of water and energy, so BMW has focused heavily on making these processes more resource efficient. At the San Luis Potosí plant in Mexico, BMW has highlighted a paint shop that recycles processed wastewater, reducing water consumption in a region where water is especially valuable. Across the group, the iFactory idea is described with 3 words: lean, green, and digital. Lean means efficient, precise, and flexible production. Green means resource efficiency, sustainability, and circular thinking. Digital means using data, AI, virtual planning, and connected systems to improve quality and speed. For the BMW 3 Series, this matters because the car is built in a world where customers expect performance and luxury, but companies also have to reduce waste, energy use, and emissions from production. So, how is a BMW 3 Series made? It begins with digital planning, where the factory is tested before the car is built. Flat metal blanks are stamped into body panels. Robots and technicians join those panels into a rigid body in white. The shell is cleaned, protected, painted, cured, and inspected. In assembly, thousands of components are installed in the correct order. The body meets the drivetrain during the marriage. Software is loaded. Fluids are filled. Electronics wake up. Quality systems inspect the vehicle from surface finish to safety functions. Finally, the car is tested, corrected if needed, and prepared for delivery. What rolls out at the end is more than a sedan. It is the result of decades of manufacturing knowledge, thousands of workers, hundreds of robots, millions of data points, and a production system designed to make every 3 Series feel like a BMW. And that is how the BMW 3 Series is made.